Howdy folks, Mr. Reed here, and welcome to one more question. We're going to be taking a look at solving some equations tonight. I'm going to do a bunch of them, so wish me luck. Have 4 of them lined up, so we'll see if we can get through it all. But in the meantime, all you care about probably is this one right now. So if you want to solve an equation that involves logarithms but is a bit on the straightforward side, we're going to do this one at a mild level. If that's what you're looking for, you're in the right place, so let's get to it. Okay, now, I'm just going to write down the question that is currently above me. So it's log base 3 of x plus 4 is equal to 2. So this is actually a pretty tidy, nice expression. There's not a whole lot going on here. So what I'm going to end up doing is I'm actually just going to take this, which is actually a logarithm written in logarithmic form, and I'm going to switch it over to being written in exponential form and see if that change allows me to understand what's going on a little bit differently or a little bit better. So how we do that is we take the base of the logarithm, which is a 3, and we raise it to the power of the thing that's on the other side of the equal sign. In this case, that's 2. If you need to see a little bit of the relationship between logarithms and exponential functions, you want to take a look at one of my other videos that explores that inverse relationship. For the time being, I'm going to assume you can kind of follow along with this. That's 3 to the power of 2 is equal to the argument, which is x plus 4. So that's the relationship that is the same relationship, just in exponential form instead of logarithmic form. Well, that's actually pretty nice because all we have to do here is take 3 squared. That gives us 9. And so that's equal to x plus 4. I'm going to say then that x is equal to 5. Now, in this particular type of example, I don't actually need to take that value and put it back into the original, but I typically should make a habit of doing that. So in this case, if I take the 5, put it back up into the original logarithm, logarithms actually have a domain that's only greater than 0. So we don't ever want the argument of a logarithm to be less than 0 or equal to 0. In this case, it would be 9, which is totally fine. Log base 3 of 9 is equal to 2 is basically what this would say if I plugged it back in. That's another thing that you should probably start to become comfortable with. If you see a value like this, eventually, at first you want to do kind of a conversion and put it into an exponential form that you feel comfortable with. So I might just say a is equal to this, just as kind of like a side note if I want to see what this is actually has a value of. And then I would say, okay, that means 3 to the power of a is equal to 9. Now that a kind of looks like a 9, probably should fix it. 3 to the power of a is equal to 9. Now that's a question I should be able to answer just by saying, oh, it's 3 squared is equal to 9. So my a is equal to 2, which is good because my right-hand side is a 2, so that means I did find the right answer here. Eventually, though, what I think you should be able to do is take a look at this thing right here, which is log base 3 of 9, and just be able to say, oh, I'm pretty comfortable with the fact that that's a 2. So work your way towards a comfort level in being able to identify for these nice logarithmic values what the actual value you're looking at is equal to. In the meantime, that was an easy or a mild version of an equation that has a logarithm built into it. So hopefully you found that helpful. That was a short one, so wish me luck on the next 3. Thanks for stopping in. If it was helpful, like, subscribe, and as always, take care, folks.